Here we determine the condition that must be satisfied by A and B so that the matrix A is orthogonal. So for a matrix A to be orthogonal, we use the condition that is the product of A matrix with its transpose, that is A times A transpose, and this must equals I matrix, where I represents the identity matrix. So let's substitute the value of this matrix A. Matrix A is A plus B, then B minus A, and in the second row we write A minus B and B plus A. This is matrix A. We now multiply this with the transpose of A matrix. So we write the transpose of A matrix by writing the rows as columns and columns as rows. So this is the first row. We write down this as the column of the transpose matrix, that is A plus B. And then we put this B minus A, and the second row will become the second column. So we write A minus B, and then A plus, sorry, this is B plus A. So this basically is the A matrix, and this one is the transpose of the A matrix. And this must equal the identity matrix. Since this one A matrix is a 2 by 2 square matrix, we write down the corresponding identity matrix for a 2 by 2 matrix. This is 1, 0, and 0, 1. Now let's do the multiplication of these two matrices. That is, A matrix should be multiplied with the transpose of the A matrix. So for that, we start off with the A matrix. We take the first row and multiply with the first column of the second matrix. And so this equals A plus B. We multiply the corresponding elements and then add them together. This must be multiplied with A plus B. So this is basically A plus B quantity square. We then put plus and then multiply the second element, that is B minus A times B minus A equals B minus A quantity square. Now let's move to the next element. And so we have to take the second column. So this will be A plus B times A minus B, that is A plus B times A minus B. We can use the difference of squares identity, and according to the difference of squares identity, we can write this as A squared minus B squared. So I write A squared minus B squared. We also multiply B minus A times B plus A. So once again, we can use the difference of square. So in this case, this will be B squared minus A squared. Now we have done the first row. Let's move on to the next row. For that, we have to consider the second row of the first matrix. Let's first multiply with the first column. So it is A minus B times A plus B. So using difference of squares, we write this as A squared minus B squared. Then we take these terms and multiply them. B plus A times B minus A is using the difference of square. We write B squared minus A squared. Now let's take the second column and multiply with the second row of the first matrix. So here we have A minus B times A minus B, and this equals, we can write this as A minus B quantity square, and then B plus A has to be multiplied with B plus A, which is B plus A quantity square, and this is in matrix form, and this equals the identity matrix, that is 1, 0, and 0, 1. So let's simplify this. And so this gives A plus B quantity square using the algebraic identity. We can write this as A plus B quantity square. This equals A squared plus B squared plus 2AB. So I'm going to write down A plus B quantity square as A squared plus B squared plus 2AB. In fact, we can also multiply by considering the term A plus B multiplied with itself. So when we do like this, that is, we FOIL this, we will get the same expression. Now let's write the expression B minus A quantity square. We will expand it. Once again, if we use this identity, we can write this as B squared plus A squared minus 2ab. So we are writing this matrix. We have completed this element. Let's simplify this element. This is negative b squared plus b squared becomes 0. Positive a squared and negative a squared, this becomes 0. So the next element is 0. Now let's evaluate this element. We have negative b squared, positive b squared 0, plus a squared, negative b squared, this is also 0. And then we will simplify this. This one is, once again, you can write this as a squared plus b squared minus 2ab. And then we will expand this. So this will be b squared plus a squared plus 2ab. We then close this one. And so this equals, I'm writing this below, 1, 0, 0, so 0, 1. Let's simplify this expression. We have positive 2ab and negative 2ab. These two gets cancelled. We have 2 times of a squared and 2 times of b squared. So we can write this as 2a squared plus 2b squared is the first element. And then this we write this second element, and in the next row we write this element first, and then we will also simplify this. This is negative 2ab, positive 2ab, 0, and we have 2 times of a squared plus 2 times of b squared. So it is 2a squared plus 2b squared, and this is in matrix form. And this equals, on the right side we have the identity matrix, that is 1, 0 and 0, 1. Now for these matrices to be equal, we should have the corresponding elements equal. That is, this element should equal this element. So we write 2a squared plus 2b squared equals 1. Factoring 2 from the left side, we get 2 times of a squared plus b squared, and this equals 1. Now dividing both sides by 2, we get the expression, that is a squared plus b squared equals 1 by 2, which is half. So we have obtained the condition, that is a squared plus b squared equals half. This is the condition required so that the matrix A is orthogonal.